Alrighty, this is going on page 111. When we're done, we have graphed trig functions, sine, cosine, and tangent. We have graphed the reciprocals, secant, cosecant, and cotangent. And now we're going to look at the inverses. Inverses are different than reciprocals. Okay, keep that in mind. They are not the same thing. So it says, in general, that a function has an inverse if and only if it is a one-to-one function. So remember what we had one-to-one functions. This means it must pass the horizontal line test to have an inverse. However, if the domain is restricted to a certain interval, the sine, cosine, and tangent functions have inverse functions. Okay? So then some terminology here, because we know about sine inverse, like we've talked about that and found those things when we're looking for angles. But it says when graphed on a restricted interval, the inverse of the sine function is the arcsine function. This is another way to say it. It's the same thing. Okay? Arcsine is written like this, R-A-R-C and then S-I-N. But that is the same thing as sine inverse. You will see them both interchangeably. Like it doesn't matter which one you use or which one you say, but they mean the same thing, so you just have to know that they mean the same thing. So just like that, arc cosine would be written like this. And then arc tangent would be like this. Okay? Either one of them, you don't write them both, obviously, but they mean the same thing. So we're going to talk about arcsine first. So here is what we've been drawing for the parent function. Looks like this from 0 to 2 pi, right? We're going to actually draw it this time from negative 2 pi to 2 pi. And we know that it actually keeps going. All right, so this is a function. It is not a one-to-one function as it is because it fails the horizontal line test horribly, right? However, if I start here at 0 and I go to here, what's this value on the x-axis? Pi halves. Okay, so if I'm here at pi halves, so far, so good, right? That piece of it, definitely one-to-one. If I keep going down, well, then it immediately becomes not a one-to-one function. Plus, these y values, aren't they already taking, like these y values, aren't they already taken care of right here? They just get repeated, right? So I can't keep going this way or it's not one-to-one. But if I go this way and stop here, what is this? Negative pi halves. Then the pink part I have so far, that is one-to-one. You agree with that? I can't go any farther in either direction. Like, that's it. But that pretty much takes care of everything, right? That takes care of every y value. And then as the x values continue, those y values just repeat. Does that make sense? Okay. So that's why our restrictions here, it says f of x equals the sine of x from negative pi halves to pi halves. So not the whole sine function, just this part. So we're going to graph that part. That means that we know that the sine of 0 is 0. The sine of pi halves is 1. The sine of negative pi halves is negative 1, right? And then we could plot some other ones in there, but we know what this function looks like, so we can just sketch that in like that. So the restricted sine function that we're using, the domain goes from what to what? Negative pi halves to pi halves, and we'll do this in interval notation. Do we include the pi halveses? Yes, we do. So these are brackets. And then our range, we go from negative 1 to 1. Do we include those? Yes. Those are our brackets. Okay. All right, so then to do the inverse. The inverse, remember, is when you exchange x and y. It's not a reciprocal. That's completely different. So if I exchange x and y, we'll start with 0, 0. Well, that's still 0, 0. Right? The point that's at pi halves 1 is now at 1 pi halves. The point that was at negative pi halves negative 1 is now at negative 1 negative pi halves. Okay, now again, we could plot some other points here, but let's think about what we know about inverses. Inverses on a graph is just a reflection across what line? y equals x. So if I reflected across this line y equals x here, then don't these points reflect down here? Okay, there's actual reflection here. So the concavity of this, like the way it opens up and down, that changes. So it looks like this. Okay. Concavity is a word. Why are y'all laughing? You're going to talk a lot about the concavity of your functions. Concave up, concave down. All right, we're good so far? So what's the domain of the arc sine function here? -1 to 1. We include them. And the range goes from negative pi halves to pi halves. And we include them. Because just like any other inverse, the domain and ranges just switch places as well. Okay, everybody good so far? All right, so you're very restricted here, your inputs and your outputs. Okay, when we've been talking about the unit circle before, we've talked about like every quadrant, and we can go as big and as small and whatever, but for your unit circle sine, see this right here from 0 to pi halves, that's in quadrant 1. From 0 to negative pi halves, this is 0 to negative pi halves, that's quadrant 4, right? And you see how all your y values are negative? So we have a positive quadrant and a negative quadrant of our unit circle taken care of. And then they just kind of repeat in the other two. We all good so far? Okay, let's look at cosine. So my cosine parent function, what we'd been sketching to be able to graph those functions was this part. So we're also going to continue this one over here, right? So just like on the other one, or for sine, I'll start here at 0. As I go down to here, which is at pi halves, so far it's 1 to 1, right? Can I keep going? I can keep going to here. And if I go any farther than this, then it's not going to be a 1 to 1 function anymore, right? Where am I here on the x-axis? Pi. Could I use the same piece that I did for sine? If I start going here and going negative, that automatically becomes not 1 to 1, right? That's a problem. So this is the piece that I get to use for cosine. I'm going from 0 to pi, not from negative pi halves to pi halves, because it's a different function. And for cosine, this is quadrant 1 to here, because this is at pi halves, right? And it's positive. This stuff going from pi halves to pi is in quadrant 2, and cosine is what in quadrant 2? Negative. And what is cosine in quadrant 4? Positive. See, it's positive right here. That's why I couldn't go this way. So I have a positive and a negative quadrant on my unit circle that I've used. Okay, everybody good so far? So we're going to plot just the purple part over here. And the cosine of 0 is 1. The cosine of pi halves is 0. The cosine of pi is -1. And then we know what cosine looks like, so we can sketch that in. The domain here goes from 0 to pi. And the range goes from -1 to 1. Right, so let's plot these points as the inverse. They change places. This 0, 1 becomes 1, 0. The pi halves 0 becomes 0 pi halves. The pi -1 becomes -1 pi. So it's not using the same part of the graph both times like it did for sine, because remember, it's like a reflection in the line y equals x, which would be right here. So if I reflected in this right here, it should make sense that this is going where it's going. And then the concavity, which makes you giggle for whatever reason, is opposite. So it looks like this. Silly. So our domain, we can see that it's from -1 to 1, and also that's the range for the other. And we can see that our range is from 0 to pi. Everybody okay with that? Any questions? All right. Let's look at tangent. So for tangent, we've started our parent function, we graphed this part. Okay. So we'll just complete a couple of them to get a fuller graph here. So we'll just continue that. And we'll continue that, just so we can see what else is going on. Okay. So that's what we would have. Keep going, repeat, 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 right? Okay. So if we treat these the same and we say, all right, we're going to start here at 0. When I get to here, this part, even all the way up to infinity, still 1 to 1, yes? We've got two options. We could keep this and just count from 0 to pi like we have, okay? That would be using quadrants 1 and 2 on our unit circle, right? We know it's positive here. Tangent's also positive here, so these are both negative. So I can either go this way or I can go this way. But this is the way the tangent is. We use that full little shape right there. So we're using quadrants 1, right? Because this goes from 0 to pi halves. This goes from 0 to negative pi halves. So we're using quadrants 1 and 4 of the unit circle. Not of this graph, but of the unit circle. So we'll graph that part over here. The tangent of 0 is 0. Pi fourths is 1. Negative pi fourths is negative 1. And we have some asymptotes, right? And so it looks like this. That is a 1-to-1 function. That restricted part there. So our domain goes from negative pi halves to pi halves. Do we include those? No, because they're asymptotes, so these are parentheses. The range goes from what to what? Negative infinity to infinity, exactly. You never include your infinities. All right, so let's look at the inverse. So we'll do the same thing we did on the other ones. 0, 0 is 0, 0. This point that is pi fourths 1 becomes 1 pi fourths. Negative pi fourths negative 1 becomes negative 1 negative pi fourths. And then your vertical asymptotes become horizontal asymptotes. So it looks like this. And then that is plenty to get it drawn in. Like so. So what is the domain then? Negative infinity to infinity. And the range goes from negative pi halves to pi halves. Okay, questions at this point? Now, all this stuff is important for the next part that we're about to do. Let's do a quick little recap up here at the top. Maybe. Eventually. Okay. So, sine inverse. Graph looks like this, right? And for the unit circle, that means I'm using quadrants 1 and 4. Cosine inverse, or arc cosine, either way, right? That inverse graph looks like this, okay? Which means for the unit circle, I'm using quadrants 1 and 2. For tangent inverse, it looks like this. And as far as the unit circle is concerned, I'm using quadrants 1 and 4. So sine and tangent use 1 and 4. Cosine uses 1 and 2. Okay, because it can't use 1 and 4 because it'd be positive in both. So before we get started on this, I'm going to ask you a couple questions. All right, so if I ask you, let's see, what is the sine of the sine of 7 pi sixths. Think about that. What is the sine of 7 pi sixths? It's 1/2, positive or negative? Negative, because we're in the third quadrant, right? So it's negative 1/2. Do we all agree with that? Okay. So, arcsine or sine inverse of negative 1/2 does not equal, sorry, I was about to write sine again, does not equal 7 pi sixths. Okay, I want you to think about that for a second. Sine inverse of negative 1/2. Negative 1/2 is my input, right? Here's my sine inverse graph. If I put in a negative 1/2, I'm going to get a negative answer, right? Because the answers that I'm going to get out of this, my range, is this part of the unit circle. It has to be a quadrant 1 or a quadrant 4 angle. That's it. Those are my only options, okay? So although I can go forwards and get this, going backwards does not give me the same answer. So the sine inverse of negative 1/2, what do you think it actually equals? What would it be in quadrant 4? 11 pi sixths. Now think about this on your graph. Does even 11 pi sixths, does that fit in your range for your output? It doesn't. Look, if your input is negative 1/2, you're going to get a negative answer, right? So although they are coterminal angles, I have to talk about those angles in a negative way, right? So this means that sine is negative, but these angles here are also, instead of 11 pi sixths, what's another way to talk about that angle? Negative pi sixths. So your answer would be negative pi sixths. Look at your domain and range for your inverse, right? The domain goes from negative 1 to 1, okay? Well, okay, I put in something that's negative 1 to 1. Your range goes from negative pi halves to pi halves. So the answers that you give have to be from negative pi halves to pi halves. Does that make sense to you? Even though there may be other answers if you go the other direction, but this is why you have to know these answers, these questions I've been asking you at the door and stopping y'all, and some of y'all take so long to get in here, and some of you still don't know them. This is going to be really hard for you, because if you can't go forwards, going backwards is almost impossible. Okay, I was not kidding. I've been pestering you with this since December. Okay, I warned you, but not everybody listens to me, so I don't know what to tell you. All right, so it says use the unit circle to help you evaluate inverse trigonometric functions. However, remember that the domain and range are restricted on trigonometric functions. Okay, so the arcsine of 1. Okay, arcsine of 1. That's something I can put in. That's from negative 1 to 1. My answer has to be somewhere between negative pi halves and pi halves. What is it? What gives you 1 when I ask you the sine of this and the answer is 1? Pi halves. Again, if you can't go forwards, it's going to be really hard to think backwards. All right, the sine inverse of the square root of 3 over 2. What gives you square root of 3 over 2? The sine of what? Use your hand trick. Pi thirds. See? Square root of 3 over 2. It's pi thirds. And this is a positive square root of 3 over 2, so it has to be in the first quadrant, so it's pi thirds. All right, what about the arcsine of negative 2? What's your domain? Negative 1 to 1. So, doesn't exist, right? Does not exist, because it doesn't even live in my, can't even do that one. All right, cosine inverse. Cosine inverse of negative square root of 2 over 2. Okay, so square root of 2 over 2 is pi fourths, right? This is a negative square root of 2 over 2. 3 pi fourths, because for cosine we use quadrants 1 and 2, and so this would have to be 3 pi fourths, because your range here goes from 0 to pi. Okay, we good? All right, cosine inverse of 3 does not exist. It's the arc cosine of -1. Pi, because, I mean, you're here, this unit circle is 0, and then, there you go, so it's pi. Arc tangent of the square root of 3 over 3. Pi 6. All right, get it from your hand. Arc tangent of -1. Well, I could go, does not exist. Can I use that or not? What's my domain? What's the domain of tangent? Even just looking at this, the domain is really all real numbers, right? It's the output that I got to restrict. So what gives you 1 as an answer for tangent? Pi fourths, right? But this is a -1. So tangent is negative, and which of the quadrants did I get to use? Because I'm only using first and fourth. So I have to use the fourth quadrant. That means my answer is what? It has to be, because my answer has to go between negative pi halves and pi halves. So it has to be negative pi fourths. Tangent inverse of the square root of 3. Pi thirds. You have to know them. Going backwards is hard enough when you know them. If you don't really know them and you're still shaky on it, this is going to be really, really hard. But I've been telling you, I gave you flashcards and stuff in December and told you, you absolutely have to know this. You have to know it. You have to know it quickly. And I mean, having to like calculate the tangents at first, I get it. Or having to calculate secant and cosecant. But the sine and cosine stuff and even tangent at this point, you've got to know them. And you've got to know them well going forwards so that you can do it well going backwards. Okay. All right, let's look at number 10. Any questions first? All right. Number 10, a ship left port A and sailed 60 miles due east to port B. Okay, we have to add something in here. From port B, the ship sailed 120 miles northwest and stopped. So we have to add something. Directly north of port A. Otherwise, the question doesn't make any sense. Okay, so I have the ship left port A, traveled due east to port B, right? And that is 160 miles. And then sailed 120 miles northwest, stopped directly north of port A, and I want to find the bearing from port B to the current location of the ship. All right, so the bearing from port B to the current location up here would mean that I'm looking for this angle right here. Y'all agree with that? So I want that angle. In the triangle, I can't find that directly, but could I find angle B in the triangle? Yes. Okay. So I can find this angle and then get what I need from there. All right, so tell me something you know about this triangle. It's a right triangle. Okay, it's a right triangle because we stopped directly north. Okay. Otherwise, it would be an assumption. So on the test, on questions like this, a lot of you still did like the law of sines and I don't know what else and made it way too hard. If this is a right triangle, just use SOHCAHTOA. Don't make it harder than it needs to be. So we're going to use SOHCAHTOA here. And let's see. I can find B first, so I'm going to use the adjacent and the hypotenuse. What's that? Cosine, right? So the cosine of B is equal to the adjacent, which is 60, over the hypotenuse, which is 120. So that means that the measure of angle B is equal to the arc cosine of, what's 60 over 120? What does that reduce to? 1/2. Okay, normally I say it reduces, but we don't care because we're going to use a calculator, but we're not going to use a calculator. Because what's the arc cosine of 1/2? Pi thirds, right? So this equals pi thirds. We all agree with that? Now, when we talk about bearing and whatnot, are we talking in terms of radians? No. So although this is what's going to pop into your head first, and it should, we really need this in degrees. So what's pi thirds in degrees? 60 degrees. Okay. So pi thirds comes first, then you know that that's 60. So then, in order to get, so this is 60 degrees, what do I do to get the angle I actually want? Subtract it from 90. So 90 minus 60 gives me that 30. So the bearing is, we would say it's north 30 degrees, what? West. There's your bearing. Everybody good so far? All right. So let's look at number 11. It says the angle of elevation from a football on a football field to the crossbar and the goalpost depends on D, the distance the ball from the ball to the base of the goalpost. So it already drew the picture for me, so that was nice. So it's A says write theta as a function of D. That's the most important part because the next part tells you to use the calculator. I told you not to get calculators today because I don't even care about that part. It's writing it in terms of a function that is the important part because you're going to have to write these things and then do other things with them where the answer itself doesn't even matter. So theta is a function of D. Is that something that we can find pretty easily? Can I set up something? What trig function would I use here? Sine, cosine, or tangent? Tangent. So I'm going to have the tangent of theta equals the opposite, which is 10, over the adjacent, which is D. So since it says write theta as a function of D, that means it's going to be theta equals, and the only variable I get to have over there is D. Well, I can solve for that, right? You just take the arc tangent on both sides, so theta is equal to the arc tangent, or tangent inverse, it's the same thing, of 10 divided by whatever D happens to be. There's your function. Okay. The B part says using your graphing calculator, it doesn't even have to be a graphing calculator, find theta when D is 75 feet, round to the nearest tenth. Well, you can substitute in 75 and solve. I'm not worried about that. Let's punch buttons on the calculator. But you have to get to this point. Like you have to set it up and have a function before you have an answer. Okay, it's stuff I've been preaching forever. Most of you do that for the most part. Not everybody does. Sometimes that's the only part of the answer, like right now. Okay. Questions? All right. Look at number 12. Read it. Label it. Try and set something up. I'm going to give you a few minutes to work on that one on your own while I pass out the assignment. Just think about what you would do if you actually had numbers for C1 and C2. You're doing the exact same thing. Okay, so let's look at this. If I had numbers for C1 and C2, then I would be able to use my big triangle, 50 and C1, and I could get this whole angle right here. Y'all agree with that? I'm going to call this whole angle alpha. You could have called it anything, x, y, it's fine. I could have also then used 50 and C2 to find this angle here, which I'll call beta. And then in the end, the theta that I'm looking for is just my alpha minus my beta. You agree with that? All right, so we're not going to do the B part, so I'm going to use this part to do the work so that y'all can see it. But so I would say for alpha, I would do the, let's see, what are we doing? It's going to be adjacent and hypotenuse, so it's going to be the cosine of alpha is equal to the adjacent, which is 50 over C1. Is that you? Yeah. Why isn't it in there? That's another reason why it should be in there. Next time that happens, it's mine. So then alpha is equal to the cosine inverse or the arc cosine, it doesn't matter, of 50 over C1. So then the cosine of beta is equal to 50 over C2, which means that beta is equal to the cosine inverse of 50 over C2. Make sense? It's the exact same thing you would do if you have numbers. Things like this should not stump you because you have variables. It's like somebody wipes your brain out or something. I don't get it. Not for all of you, but for a few of you at least. So then it says write theta as a function of C1 and C2. Well, here I have theta as a function of alpha and beta, which is not what it asked for. But now that I've solved for alpha and beta, I can substitute that in. And theta is equal to, and that way you also get them. Writing something down like that also ensures that you're going to subtract correctly. Because right now, you have no clue what these values are, right? And if you subtract them backwards, you're just wrong. So alpha is the cosine inverse of 50 over C1 minus the cosine inverse of 50 over C2. Can I simplify that at all? No, don't even try. We good? Any questions? You have to be able to take everything that you have done with numbers and values to punch buttons and give me answers to be able to also write them functionally and not freak out. Okay? Any questions? All right, so go ahead and glue or tape this in, and you have time to get started